glad that some of you could make it. I'm going to give this talk, and then I'm running to the other end of the building here, so I'm getting a lot of exercise, I think. The title is Establishment and History of the Georgia Tech Graduate Program in Aerospace Systems Design, which is remarkable, as you'll see in these charts I've got. And also, if you want to come down into the exhibit area, I've actually got a paper that describes this, as well as the other paper I'm giving down at the end of the hall. So if you want to do that. But anyway, I'm going to get through this pretty fast because I know there's others. This is just an outline of different methods and techniques that we did over the years. I don't want to read all of these, but these are described in the paper as well. One of the things when I got to Georgia Tech in 1984, it was mainly an aeronautics school. And the reason I was hired was because the Vertical Lift Rotorcraft Center was there. And so I came from St. Louis, where I was in charge of future aviation systems for the Army. And so I came down there, and I also taught 2 weeks a year up at West Point. And the key with all this stuff is you got to have a decision-making approach where you can make your trade-offs. And that's a theme here, and that's also the theme down the road where the Army doesn't know how to make these trade-offs. We did it on the Black Hawk, the Apache, the AHIP, and all these aircraft. And I tell you, the Army record, as you'll see in this chart, is pretty pathetic. But anyway, I'm going to keep going down here. I wanted to establish a graduate program in aerospace system design. They didn't want just, they won this Center of Excellence in Rotary Wing, but they wanted spacecraft design and everything else. So I had a free rein to hire people, okay, which was kind of neat. And so by the early 90s, we had established a graduate program in aerospace systems design, which covered, as you can see, all these vehicles on the left and all these methods and techniques. And we also use something called integrated product and process development. Some of you older people might know this, but that was a big thing in the 1990s. How do you make trade-offs between product and process, okay? And so basically we developed this in our curriculum and it was used, and it's been used in industry. We had contracts with Boeing, with NASA, Sikorsky, a whole bunch of different companies around to do that. But this is how you got to make trade-offs. And it's kind of pathetic that these aren't done today the correct way. So we had to do it. We did it with both fixed wing and rotary wing aircraft. And some of you know what the F-86 was. It's a neat fighter, okay? And if you want to look on my website, there's a great video. If it's not there, it will be there shortly, because we did this study for Boeing on the F-86 and had a team do this for about a year and a half. It's really some neat stuff that you might want to see. So we did that. We also did rotary wing, obviously, because we had a Center of Excellence in rotary wing. And here, how do you make these trades, okay? How do you make these trades between systems design? That's very important. And the other thing is, and traditionally, our design freedom follows that chart on the left. And the problem with that is that that wasn't getting it done. This whole idea of concurrent engineering and design and comparative like that, you don't hear anybody talking about design too much today, right? They got other acronyms they want to do, whether it's a different lot of things. But in reality, it's all about how do you make the right trades. And I'll show you a little bit later. It's a shame because the Army's really dropped the ball in the last 20 years. I mean, when I was there in the 70s and 80s, we had success programs. There hadn't been no success programs for Army aviation since, if you want to know the truth. That's how bad it is, okay? So anyway, this is a method here. And like I said, the figure on the upper left is, I was also given a task to hire people. We hired some great people. Dr. Dave Peters, some of you know him, Dr. Dewey Hodges, different people. We had, so it became a multi-university center. It wasn't just Georgia Tech, you know, and we had this center. And this is how you did the trade-offs in the circle there, okay? And then we formed Aerospace Systems Design Laboratory in 1992 with a guy named Dr. Dimitri Mavris. And if you've never heard of Dimitri Mavris, he's probably the most influential aerospace engineer professor in the world. And I'm just not saying this, man. He's recognized throughout the world, okay? Now, these are design competitions, and we use these design competitions to show how you could do these kind of designs and trade-offs. And we were very successful for about the first 10 years. Then we formed this Aerospace System Design Lab, and they were doing everything from spacecraft to autonomous unmanned vehicles, everything else. So it got expanded that way. Two of the teams that were there, one of them is Tom Thompson. Some of you might, if you know anything about Army aviation, he's the chief of aeromechanics for the Army down in Huntsville. Tom was one of our first graduates. Tom's got a personality that's unbelievable. In fact, if you look on my website, there's a video when I retired, and Tom gets up and makes some real comical remarks. It's on my website, but it's really good. The guy on the right might be a little famous too, because he was the chief of staff of the Army a couple of years ago. And then he came down and gave me, when he retired, and he said I was the best professor he ever had, and he gave me a big plaque and everything I've got hanging in my room. So it's some reward to do that afterwards. This program we built up, it's really hard. One of the themes of this, I published 2 books, and this book that is going to be published in June, it covers 35 years at Georgia Tech. So it's going to have a lot of information in it. If you want to come by the booth down there, actually the vertical flight booth, I can talk to you some more about this. The other 2 books I've been selling quite a bit. They're kind of like a memoir, of different things, because I had a kind of interesting life. I've done a little bit of everything when it comes to military aircraft, missiles, Honest John missiles in Germany, flying helicopters in Vietnam, all these different kinds of things that are involved. But these courses, you can see, were pretty extensive. That doesn't mean you can sustain these in the university. One of my themes for this book number 3, we built up something really great, but it's hard to sustain something like that because faculty are kind of independent. They like to do their own thing, right? And trying to get them all to follow a sequence of events. Nick's sitting back here smiling because he's been on the Georgia Tech Advisory Board. He knows what I'm talking about. One of the things that we tried to do, too, was bring in safety by design flight certification. And that's very, very important, okay? And yet you don't see any of that very much in engineering organizations. But I've been on committees for the SAE committee for a number of years, developing these different tools. And this becomes very important. And you see that yellow in the middle where it says Open IMA. There's a lot of words out there about the approach that they're trying to take today, with modular systems approaches and all this kind of stuff. I don't think they know what they're talking about. Nick and I have been following them for about a year now. They're still trying to figure out what is this about. I could explain it to them. In fact, I'm giving a talk, Nick, sometime in August to that group again. Maybe something else will happen. Yeah. The other thing is that we were able to do, we did some stuff in 2004. Everybody talks about drones and autonomous vehicles. We had a DARPA program with the top universities in the United States. We demonstrated some unbelievable stuff. I want to show you a chart a little bit later if I get to that. Okay. The other thing is this concurrent engineering. Some of you don't remember that, but everybody was trying to keep up with the Japanese, that total quality management. Some of you older guys might remember that. But, and then integrated product and process development requires the fact that you got to do these trades between product and process. If you don't do that, it's going to be a failure, okay? The next chart is kind of interesting because one of the jobs I was told to do is that School of Aeronautics was an aeronautical institute, and that's when some of us were there a long time ago. And they said, we need to become an aerospace school, okay? So I had a free charter. I hired spacecraft guys. I had a whole bunch of different guys. But we went, I'm kind of proud of this, because from 1990 to 2000, we went from number 14 in the school, it's called Schools of Aerospace, but it was really aeronautics schools. And by 2000, we were in the top 3. And to this day, we're in the top 1 or 2 every year. And we're by far the largest aerospace school in the world. I mean, I'll show you that in just a little bit to see how big that is. Another big contributor to this was a good friend of mine. A lot of you knew Bob Lowy. Bob Lowy is a great guy. I've known Bob for a long time. Bob and Al Gessau, we were 3 center directors when they first kicked off these Rotorcraft centers. It was myself at Georgia Tech, Bob Lowy up at RPI, and then Al Gessau at Maryland, okay? And then what Bob Lowy said was, geez, I see what's going on at Georgia Tech, and they got an open position for a school chair. So he came down and became the school chair for about 10 years at Georgia Tech. And so he helped with kind of this movement because he had a little bit more credibility maybe in the academic community than I did, okay? This just shows you how far ahead, how many students we have compared to the rest of aerospace schools in the world. We're about 3 or 4 times, and I'll explain why this number is so large in just a few minutes. There's a laboratory that I started in 1992 with a guy named Dr. Dmitry Mavris. And if you don't know Dmitry Mavris, he's the world-renowned aerospace professor. And I'm not just saying this. I mean, he was a protege of mine. He was a postdoc of mine. And you can go, I call him up on the phone. One day he's in Australia, one time he's in Japan, one time he's in France. The guy's amazing, and he's by far the highest ranked professor at Georgia Tech, which is pretty impressive. Really a good guy too, the hardest worker you ever meet. I finally decided, let him take over and I'll get out of his way and I'll do some other things, okay? But the vision for this is unbelievable. I'm gonna flip through these fast, you can't see it very well. But you don't think this is the biggest laboratory in the world? Take a look at that picture on the right there. How about 300 graduate students? How about 100 research engineers, okay? How about 50 faculty? There ain't no aerospace school in the world. Just by this laboratory, it's bigger than 95% of all the aerospace schools in the world, okay? It's amazing what's been accomplished in there. And they got a lot of interest. You know, when Trump came out with this idea of the DOGE was going to get rid of all this stuff, I said, man, we do 50 grand challenge projects with industry, government, Air Force, everybody else. I think that might have been a more credible approach than just taking some guys from his company, you know, and saying these guys, they're smart maybe, but we have a method to do this, trades, that became very important. So anyway, what's a grand challenge? We started this with, you know, 25K from an industry, NASA, a bunch of companies. This past year, we just had a review about 2 weeks ago. We had 51 grand challenge projects. 51 grand challenge projects. Can you imagine how many that is? Some other things we did was, you know, we tried to support the Future Vertical Lift program. In fact, by talk, I got to run out of here down to Hall because I think it was a crying shame that the Army didn't know how the hell to select a future attack and reconnaissance aircraft. I got nothing against, you know, the tilt rotor because I think that was good. But hey, I know all about coaxial compound helicopters going back to the 60s, guys. And the best coaxial helicopter ever built was the X2 prototype. If you looked at the X2, the frequencies were in the right place, everything was in the right place, and that made the most sense. And another thing was the Joint Common Architecture. You know, that was supposed to be for future vertical lift. That kind of got sidetracked, okay? Now, this is a program I'm really proud of because from 2000 to 2005, we had this DARPA contract and it worked with all the industries. And what we were trying to do was intelligent and autonomous unmanned vehicle control. And there's a video, if it's not on my website, it will be there. And it will show what we accomplished in that time frame, which nobody else has accomplished, even today. How would you like to have an autonomous vehicle that launches another autonomous vehicle? You got anybody in the world that knows how to do that? We demonstrated that a long time ago. So anyway, this was the team we had. A great team. We had Honeywell, we had Draper, we had Boeing, we had Georgia Tech, we had Oregon, we had all these people were involved in this thing. And no doubt, this was by far, this is down at by Fort Benning down there in the urban terrain village. And we did all kinds. There's a great video. If you want to watch a great video of how this actually took place, it'll be on the website. I'd like to acknowledge this precursor for book 3. Dmitry Mavris, director of ASTL, is one of the major contributors to this paper. A couple of other people that teach the courses I used to teach. It's kind of interesting. We had a review last week, and all these guys come from the Air Force and everything else, and they say, hey, I was in your life cycle cost class as an undergraduate, and we wanted to make that benefit, that cost. Nobody does that otherwise. The government doesn't do that. Oh, we take the best value program. What the hell do they know? They don't know how to measure. If you really want to know how to do a development assurance value-based approach, run down the hall and I'll give you the second lecture. But if you come by the booth, I'll give you the paper that describes why the FAR aircraft should not have been killed. Now, I just found out from Bell, they just killed the T901 engine too. So they're in some bad shape. So I think that was, this is my trilogy signing. These 2 books on the left over here, I published those in the last year or 2. And the book 3, which is my 35 years at Georgia Tech, took a little bit longer, okay? But the 2 papers I have at the forum here are kind of feeders, precursors. that go into this bigger book. I'm about 2/3 done with this bigger book. When you're talking 35 years, there's a lot of things to cover, let me tell you. So I think that's it.